Okay, in this video, we are going to study how to graph the transformations of functions. Now, before I introduce these transformations, I would like to show you some basic functions and their graphs. So we have four basic functions. The first one is the function squaring function, which is our quadratic function. So the function is fx equals x squared, and the graph is a parabola, and this parabola sits at the point 0, 0. The second basic function is the cubing function, fx equals x to the third, and the graph of the cubing function is like this. So the function is an increasing function. And the third one is the absolute value function. Okay. And the last one is the square root function. So in this video and the next videos, I will show you if we do some change on these functions, and then we will see how do their graph change. So we have we are going to study three transformations. The first transformation is called translations, and we have two types of translations. The first one is vertical translation, or sometimes it's called vertical shift. The second one is horizontal translations, or horizontal shift. So here is the definition. We let fx be a function and c be a positive real number. And if we add or subtract a number after the fx, so we're going to generate a different function. For example, if we add this positive number after the fx, the function we generate is a gx, and the graph of the function gx is the graph of the fx shifted upwards for c units, and the graph of the function gx equals fx minus c is the graph of fx shifted downward for c units. So let me use this example to show you what is a vertical shift. So for example, here we have this squaring function, right? Now what if we are given the function gx, and the gx is equal to fx plus phi, which is x squared plus phi. Now to graph the function gx, because here we're adding a positive number after the fx, so this is a vertical translation. So to find the graph of gx, we just need to shift the graph of fx upwards for 5 units. So if we move this entire piece up for 5 units, you will get something like this. So we didn't change the shape of this parabola. All we do is change the position of each point. We shift it up. We shift every point up for 5 units. And what if we define a function fx minus 1? So this time we want to graph the function gx equals x squared minus 1. So this time we're gonna shift the function downward for 1 unit. So we may get something like this. Okay. So this is what does vertical translation mean. Okay. Now let's go back to here. Now the second translation is called horizontal translation or horizontal shift. So this happens if we add a number to x or we subtract a number from x within the parentheses. So if we add a number to x within the parentheses, the graph of the new function gx is the graph of fx shifted horizontally left for c units, and the graph gx equals f of x minus c is the graph of fx shifted horizontally right for c units. So for example, this time I have this function, this square root function, and for example, I would like to graph f of x plus 3. Now, f of x plus 3, if we write down the expression of this function, the expression will be the square root of x plus 3. Now, this time, since we are adding a positive number to x, so according to what we just saw, we should shift the graph to the left for 3 units. So we will get something like this. So this point, it is shifted from 0, 0, right? At the beginning, this point was at 0, 0, and then it is shifted to negative 3, 0. Now, what if I wanna graph function f of x minus 2? So this is like I wanna graph the function the square root of x minus 2. So this time I'm gonna shift the function to the right for 2 units. So I'll get this. Okay. So this is gx, and this is hx. Now the common mistake when students study the horizontal shift is sometimes they couldn't figure out the directions. They couldn't figure out should they shift the graph to the right or should they shift the graph to the left. So the way I remember is like this. So for example, when we take a look at this function, and if you think about this expression x plus 3, okay, and then you think about, okay, which number will make this expression be 0? In other words, you want to think about what is a solution to this equation. So the answer is negative 3. Okay, since negative 3 is a negative number, and which direction is the negative direction? The left is the negative direction, right? Because all the negative numbers are on the left side. So therefore, when you have x plus this plus 3, you should shift the graph to the left for 3 units. So therefore, you will end up at negative 3, 0. I mean, this point will be end up at negative 3, 0. And for x minus 2, if you think about the same question, then the answer is positive 2. Positive 2 will make this be 0. So that's why here we want to shift the graph to the right, to the positive direction for 2 units. Now, sometimes we have both horizontal translation and vertical translation. Okay, so for example, we have this squaring function, and we want to graph we want to graph this function. Now here, this function gx, it involves two translations. It involves the horizontal translation and the vertical translation. Now, if we have both translations, the order we perform is we recommend a student to do the horizontal shift and then do the vertical shift. So which means if I want to graph this function, I'm gonna do this in two steps. So step one is I'm gonna graph, let me use another notation. I'm gonna graph x plus 1 square. So x plus 1 square, this is like f of x plus 1. So here is my basic function, and because I have x plus 1, so I'm gonna shift this graph to the left for 1 unit. This is a horizontal translation, so I will get this graph. Okay, this is fx plus 1. And then in step 2, we add this vertical translation. So gx now is equal to hx minus 4, which is x plus 1 square minus 4. So now I will shift this graph. I will shift this orange one down for 4 units. Let me use a different color. So I will need to shift this down for 4 units. So I get something like this. Okay, so this red one will be the graph of this function gx.